Welcome to Physics Hub. My name is Sahin Sorifi and I am a research scholar at IIT Delhi. I also teach on Unacademy. So in today's video, I would like to discuss the second part of mathematical physics assignments. So a few days back, I uploaded one video relating the assignments on mathematical physics. So there I discussed 5 problems. Today also I will be discussing some problems from this mathematical method section. And these questions are very standard questions and important questions. So I am just trying to show you different types of problems which come from this mathematical method section in your NET exam. Okay. So without any further delay, let's start. Before starting, I would like to tell you that please follow us on Facebook. We keep on sharing different kind of important notifications, study material and many other things related to physics on our Facebook page. So you should follow that page. Okay. So let's start with the first problem. The first problem is from differential equation and it reads like this. Consider the differential equation d square y by dx square plus 4y equals to sin x plus cos. Let us just write the differential equation first. So this is a differential equation given to you, subjected to the initial conditions y at x equals to 0 equal to 1/3 and y prime at x equal to 0 is 1. What will be the value of y at pi by 2? And you are given 4 options. So you can see, you can observe here that this differential equation is non-homogeneous in nature. So we have to find out the homogeneous solution and we need to find out the particular integral as well. So let us just try to find out the homogeneous part yh. Okay, how do we define that? How do we find out that? We just write the homogeneous part of this differential equation by equating the non-homogeneous part equals to 0. So this is the homogeneous form. Homogeneous form. Now how can we find out the solution corresponding to this homogeneous differential equation? This is so straightforward, you know. So we can write the characteristic equation m square plus 4. Okay, this is equals to 0. Characteristic equation will give you two roots. The two values of m are m equals to plus minus twice I. Okay. Then we can write the homogeneous solution yh equals to, what we can write? We can write it c1 cos 2x plus c2 sin 2x. Okay, so how can we write this? I am just giving you the formula. Okay, so if m1 and m2 are two complex conjugate roots, okay, like if m1 is alpha plus I beta and m2 is alpha minus I beta, alpha is the real part, beta is the imaginary part, then the solution is written like this: y equals to, let's say, c1 prime e to the power m1 x, that is alpha plus I beta into x, plus c2 prime e to the power alpha minus I beta into x. Okay, and if you simplify it in terms of cos alpha x, sin alpha x, okay, sin beta x, then you will get it like this. Okay, so here you can see alpha is 0, so e to the power 0 into x is 1, so that is why the solution is written like this: c1 cos 2x plus c2 sin beta x. Okay, now once the homogeneous part is found, we have to find out the particular integral. So how can we find out the particular integral? Okay, so I am just keeping it as it is, homogeneous part, keeping it aside, and we are just trying to find out the particular integral. Okay, so we are just writing this operator. So we are just writing the operator d, which is equivalent to d dx, and d square is, for obvious reason, it will be d square by dx square. So we can write it in this way, and accordingly we can write the particular integral. Instead of y, we should write it like this: particular integral. Particular integral will be 1 by this d square plus 4. Okay, and it will be applied on sin x plus cos x. Now we know the rule of particular integral. Then if we have a function, sinusoidal function like sin ax or cos ax, so in place of d square, we will just replace it by minus a square. So here a is 1, So we will be replacing it by minus 1, minus of a square, okay, not minus a whole square. It's like minus of a square. So we will write it in this way, 1 by, this will be replaced by minus 1 plus 4 sin x plus cos x. Fine. Now it is giving you 1/3 of sin x plus 1/3 of cos x. So we got the both part, particular integral and homogeneous part. Therefore, the actual solution y is written as a summation of these two things, y homogeneous plus particular integral. This is also called complementary function sometimes. Okay, so it's your choice what you write. C1 cos 2x plus C2 sin 2x plus, we are just taking 1/3 common, sin x plus cos x. Now in this solution you see there are two unknown constants, and in the question you are given two conditions as well. So we will utilize those two conditions and will eradicate or eliminate these two unknown constant. We will try to find out the value of y at x equals to pi by 2. So just utilize the first boundary condition or initial condition given to you, y at x equals to 0 is 1/3, where it will lead us to. So we'll put it here. So y at x equals to 0 is 1/3, and putting x equals to 0, you see cos 2x means cos 0 means 1. So C1, and this sin term will vanish, this cos term will remain. So 1/3, C1 plus 1/3. Okay. So we can see that C1 is 0 basically. Now again we'll utilize the second boundary condition which is given to us. What is that? It is y prime at x equals to 0 is 1. So let us just redefine the solution y. Y equals to this, we will just put the value of C1 to be 0 here. So it will become C2 sin 2x plus 1/3 sin x plus cos x. So if you write it in this systematic way, then the solution looks very good. So first of all we have to find out y prime, because we have to find out the value at y prime. Okay, so this is giving you, and plus 1/3 taken common, cos x minus sin x. Now in the question it is given y prime at x equals to 0 equals to 1. Okay, it is given like that. Yes. So we will try to find out the value. So y prime at x equals to 0 is 1 plus 2 C2 cos 0 is 1, so 1 plus 1/3 cos 0 is 1, so 1, and sin 0 is giving you nothing. So from here we can see C2 has got the value 1 minus 1/3 means 2/3, so it's basically 1/3. So we evaluated the value of the two unknown constants. So our final solution become y equals to C2 sin 2x, so 1/3 sin 2x plus this plus 1/3 sin x plus cos x. Now what else? We have to find out the value of y at x equals to pi by 2. So y at x equals to pi by 2, it becomes 1/3 of sin 2 into pi by 2 means pi. Okay, 1/3 sin pi plus 1/3 sin pi by 2 plus cos pi by 2 is, although 0, but for the sake of completeness I am just writing everything. So it is basically 1/3. So it is matching with the second option, option B. So option B is the correct option for this question. Let us just quickly move forward to the next question, question number 2. If Hermite polynomial of order 2 is given by h2 of x equals to ax square minus 2, h2 of x equals to ax square minus 2, where this condition is very important, a is greater than 0, then the value of a is. So how can we solve this question from a special function? Orthonormality condition for this Hermite polynomial is given by this minus infinity to plus infinity h n x whole square, okay, e to the power minus x square dx, this is equals to 2 to the power n into n factorial root over pi. Okay. Now what will you do? We will just put n equals to 2 directly into this formula and we will see what we are getting, and then we will just match this with the given expression and we will get the value of a. This is our goal. So for the first step, what you will do for n equals to 2, we will just put the value here, n equals to 2. So it will give you minus infinity to plus infinity h2 of x square e to the power minus x square dx. Okay. This is equals to 2 square 2 factorial root pi, means this is basically 8 root over pi. Okay. So this left hand side can be written like this, minus infinity to plus infinity. H to x is given to you by this expression ax square minus 2 whole square e to the power minus x square dx. This is equals to 8 root over pi. Okay. Now we will just evaluate this integration and that will give us the result. So a x to the power 4 minus 2 into 2 into ax square means 4 ax square minus, so this is plus 4 e to the power minus x square dx. This is equals to 8 root over pi. Okay. So we can write minus infinity to plus infinity. We are just separating everything. So a x to the power 4 e to the power minus x square dx. Next term minus 4a x square e to the power minus x square dx. Now the main task is to evaluate this integral. So let us just write the formula first. What do we know? We know this formula. Okay. We know, and this is a known formula, you have to remember this, otherwise it will be very difficult to solve this problem. Minus infinity to plus infinity x to the power n e to the power minus ax square dx. Okay, this is the formula that will give you 1 into 3 into 5 and it will go like this up to n minus 1, okay, into root over pi by 2 to the power n a to the power n plus 1. Okay, and this is valid when n is greater or equals to 2 and even, and if n is odd then this value will give you 0. Okay, now we will just utilize this formula here. So here you can see a is taken common, a is constant, so it is coming outside, not taken common. X to the power 4 e to the power minus x square dx. We have written dx everywhere, so why should it be? Look like this. X to the power 4 e to the power minus x square dx. So here a is 1 and x to the power 4 means n equals to 4. So it will go up to 1 into 3. So 3. Okay, 3. Then root over pi by 2 to the power n. N is 4 here, so 2 to the power 4, a to the power n plus 1, a is 1, so 1 to the power many things is 1 basically. So this is giving you this term, the first term is giving you this minus 4a x square e to the power minus x square dx. So x means 2, so this will go up to 1, so root over pi by 2 square and that is 1 plus 4 e to the power minus x square dx. Now x to the power n means x to the power 0. Okay, so it is valid for n is greater than 2, and you know this standard formula e to the minus x square dx to root over pi by a, you know this. Okay, so this is root over pi by a is 1. Okay, that is equals to 8 root over pi. Okay, so this is giving you 2 to the power 4 means 16, so root over of 16 is 4. So 3 by 4, I made a mistake here, everywhere a square will be there, because I understand, okay, a square will be there everywhere. So 3 by 4 a square plus minus this 2 square, the 2 will come outside, so 2a, and here plus 4 and root over pi is coming from everywhere, a to pi. Okay, is that fine? Now we can omit this root over pi from both sides. Okay, now we are getting a quadratic equation. Let me just write it here. The quadratic equation is written in this way: 3 by 4 a square minus 2a plus 4 minus 8, which is minus 4. This is equals to 0, and this is becoming 3a square minus 8a minus 16. This is equals to 0. This will give you two values of a. So we are getting 3a square minus 8a minus 16. So we can write it in this way: minus 12a plus 4a minus 16. This is equals to 0. So take 3a common, a minus 4 plus 4 common, a minus 4. This is equals to 0. This is giving you a minus 4 into 3a plus 4. So either this can be 0 or this can be 0, but this will give you the value of a to be negative. But in the equation it is said that a must be greater than 0. So this solution is valid. A minus 4 must be 0. That will give you a equals to 4. So the value of a is 4. So and it is matching with option B. So option B is the correct option. Okay, so guys, I have come to the PC now, and we'll discuss the remaining problems on PC. So let's discuss problem number 3. The value of the integral 0 to 2 pi d theta by 13 minus 5 sin theta is, you are given 4 options. So how can you do this problem? So you can see, we'll convert this integration in terms of the complex integration. So we are taking a contour of unit circle. Okay, the radius is 1 and it is taken in counterclockwise direction. So this circle is basically mod of z equals to 1, which this circle is centered at 0 having unit radius, and you know this, that we can convert this limit 0 to 2 pi into this complex contour, and d theta will give you dz by iz. Okay, because your z equals to e to the power I theta, therefore dz will become I e to the power I theta d theta. Okay, so that is equals to I z d theta, and that gives you d theta equals to dz by iz. Is that fine? That equals 13 minus and sin theta can be written by z minus 1 by z, because z equals to e to the power I theta. So this can be written in this way. Now we have just evaluated this thing, and we got 26 iz minus 5 z square plus 5 by twice iz, and after doing some simplification we are getting this thing. I think you can do it by yourself. So we are getting it. Now we have got the straightforward form I z square minus 26 iz minus 5. Once we evaluate the poles, and we will be able to evaluate the residue, and using Cauchy's residue theorem we can evaluate the integral. So to find out the poles, we have to set the denominator equals to 0. So we have set the denominator equals to 0, and by using Sridhar-Acharya's formula we got the value of z, means we got the poles. One is 5i and another is I by 5. Now as I told that we have taken a contour which is having unit radius, and as this 5i is lying somewhere between here, I, 2i, 3i, 4i, 5i, means basically lying outside this contour, but this I by 5 is lying somewhere here. Okay, this is I by 5. So only I by 5 is lying inside the contour, so only I by 5 will be taken into consideration, and residue at z equals to I by 5 is found out. This is simple pole, so we can find out in this way: z minus a into a plus z, limit z tends to a. This is the main formula, and we can find out the value of this residue as I by 24. So 0 to 2 pi d theta by 13 minus 5 sin theta it becomes, and minus sign was there already. Okay, this minus sign, minus 2 pi I into 2, minus 2 was there, so we have taken minus 2, and similar we have utilized twice pi I into sum of residue I times by 20, that is giving you pi by 6. It is matching with option B. Okay, so we have utilized Cauchy's residue theorem. Cauchy's residue theorem, According to that, if some contour consisting of some pole, then this integration over that contour f of z dz equals to twice pi I into sum of residue. We have utilized this formula here. Straightforward formula. This is question number 3. Let's discuss question number 4. But before that, I would like to tell you that if you are enjoying the video, just give it a thumbs up. Okay. Now let's discuss this problem. Problem number 4. This problem reads like this: a matrix C is given by this 0, 0, I, 0, I, 0, I, 0, 0. Using similarity transformation, matrix C is transformed into a diagonal matrix D. Then what will be the matrix e to the power pi d is given by? This is what is the value of e to the power pi d. So this is also very interesting question. How can we do that? We have to know about the similarity transform. So let us just look at the solution. This matrix, this is symmetric matrix. Okay, and we can find out the eigenvalues of this matrix. Okay, so we got the eigenvalues to be lambda 1 equals to I, lambda 2 equals to I, lambda 3 equals to minus I. You can see the calculation, detailed calculation have been shown here. I am not explaining these things because this is so straightforward. Once you got the eigenvalues, we can find out the diagonal matrix D. Okay, the diagonal matrix is written like this: I. By writing the eigenvalues diagonally, you get the diagonal matrix, and hence e to the power pi d will become e to the power pi into I, e to the power pi into I, and e to the power minus I into pi. So it's basically e to the power lambda 1 into pi. Okay, e to the power pi d, so e to the power pi into lambda 1 you can say. And you are getting it minus 1, and minus 1. Okay, and it is matching with option B. So option B is the correct option for this question. Let's quickly move toward the last problem of this side. The value of the legendary polynomial Pn of x for odd value of n and x equals to 0, that is, Pn at x equals to 0 is. So how to evaluate this? This is also very good question from a special function. So we know the generating function of legendary polynomial 1 minus twice xt plus t squared to the power minus half. This is equals to n equals to 0 to infinity Pn of x to the power n. Okay. Now we have to find out the value of this legendary polynomial at x equals to 0. So we'll just put x equals to 0 in the generating function, and we get 1 plus t squared to the power minus 2 or 1 is half, that is equals to Pn at x equals to 0 t to the power n. Now we can expand this term in binomial expansion. So we get 1 minus half t square plus minus half minus 3 by 0. This is standard expansion. It's like 1 plus x to the power minus n. This expansion formula is being applied here, and we are getting this thing. Now you just compare the terms on both sides. Before comparing the term, we will just match it like this: 1 minus t square by 2 plus this 3 by 4 t to the power 4 dot dot dot. You have to find out Pn at x equals to 0. Okay, so Pn at x equals to 0, t to the power n. Now comparing the odd terms, we have to find out the value of Pn of x at odd n. So you can see there is no odd term present in this expansion. So Pn at x equals to 0 for what values of n will be equals to 0. So it is matching with option B. So option B is the correct option for this question. So today in this assignment, second part of mathematical physics assignments, we discussed about 5 problems, and if you have any kind of question or query regarding these 5 questions, you can comment down in the comment section. I will try my best to clarify them all. And I would like to tell you that I also teach on Unacademy, and I cover the whole syllabus of CSIR-NET Physical Science. Okay, and I take the classes in English language. So language is not a barrier. So if you want to join my classes, you can join using our referral code Physics Hub, and Unacademy will offer you 10% off on overall fee. And if you are a new visitor of this channel, please subscribe the channel and do not forget to press the bell icon. And lastly, I would like to tell you that please follow us on Facebook, because we keep on sharing good content on Facebook. And this is all for today, guys. See you in the next video. Bye bye. Thank you.